We will now proceed with simple flow of control. In C++, flow of control refers to the order in which statements are executed. We can also have branch, which lets programs choose between two alternatives. As an example, we would like to calculate the hourly wages and there are two choices. If such is the case, then we can use a branch statement. For instance, we have the following choices. An employee can be paid with its regular time with the following calculation. Its gross pay can be derived from its rate and the number of hours that has been worked. Or it can be an overtime for those which are over 40 hours. And the following equation can be used. Therefore, the program must choose which of these expressions to use. If that's the case, we can use a branching statement. But first, we must know how to design the branching statement of our program. Therefore, we must decide if the number of hours is greater than 40, then that would be an overtime. Otherwise, we can simply compute the salary using the regular formula. Now that we know the logic behind our computation, it's now time for us to implement the branch. In this case, we can use the if-else statement. In C++, we can use this to perform a branch. If we are going to implement that into an actual C++ source code, we have the following. As you can see, we have the if statement. It contains the first option, which determines if the number of hours worked is greater than 40 hours, and therefore, the computation for overtime pay will be used. Otherwise, we will simply use the regular computation. Here's a sample program for that. For instance, we have this program which determines the gross pay of an employee, whether it's a regular working hours or overtime. First, we need to declare the following variables. Then, we need to enter the employee's rate through the cin statement, as well as the number of hours worked, and determine if the number of hours worked that was entered is greater than 40. If it's greater than 40, then we will have to calculate the overtime pay. Otherwise, it's just the regular pay. We must also take note that we are now using the following function, which we have seen in the previous section. Of course, our intention is for us to properly format the output of our program, which uses double type variables and display them on our monitor. Thus, we must first use our formatting before we use the final cout statements, which will display the value of our variables. Let's try to run this program. For example, the hourly rate of an employee would be $55. And the number of hours worked, let's say 38. So that would be the gross pay of our employee. Let's try another example. This time, the employee would have an overtime pay. Let's say the rate is $55. Then the number of hours worked is 42 hours. So that is over 40 hours. Therefore, we have the following gross pay. That is just a simple example, because in this case, we only have two options. One for the overtime pay and one for the regular pay. Actually, branching statements are quite easy to understand. For example, we have this syntax for an if-else statement. From our previous example, we can have a single statement for each alternative. In this case, we have two options. First, we just need to use the keyword if, then followed by the Boolean expression in close and parentheses, then followed by the statements that would be executed if the first expression is met, which means this Boolean expression produces a true value. Otherwise, if this produces a false value, then the statement under the else clause will be executed. Also, if the statement under your Boolean expression contains two or more statements, then we have to enclose those statements inside these braces. Same also with the statements under the else clause, they also need to be enclosed in curly braces. Next, let's talk more about the Boolean expressions that we use in our if-else statement. Boolean expressions are expressions that are either true or false. For instance, we have the comparison operator, such as this, which evaluates if the value to the left is greater than the value to the right. For instance, in our previous example, we would like to have a Boolean expression which would determine if the number of hours worked is greater than 40. This is an example of a Boolean expression, and take note that it must be enclosed in parentheses. And we must also take note that a few of the comparison operators that use two symbols, there will be no spaces allowed between the symbols. Here's an example. This is a Boolean expressions which would be used to determine if a value is greater than or equal to another value. This was also used to determine if the value is not equal to another value. Thus, this is the Boolean expression for inequality. And the other one, this is used to determine if two values are equivalent. Take note that this is different from the assignment operator. Here are some of the comparison operators that we can use in our branching statements. As we can see here, we have the equality operator, less than or equal to, greater than, and of course some other comparison operators and some examples on how we can use them. Next, let's talk about the if-else flow control. If we will recall, this is the basic syntax of an if-else statement. When the Boolean expression is true, only the true statement is executed. Otherwise, we will execute the statements under the false statement. Next, if the statements is more than two statements long, then we can just enclose them in curly braces such as this one. We also have the AND operator. Boolean expressions can be combined into more complex expression using the AND operator. In C++, we put the following operator to signify the AND operation, thus allowing us to combine multiple Boolean expressions to come up with more complex expressions. For instance, we have the following. We would like to combine two Boolean expressions, and of course, this would give us a true result if both of these expressions would result to true. For instance, we have the following example. If 2 is less than x and x is less than 7. This would be true only if x is between 2 and 3 and 7. Next, we also have the OR operation. The OR operator is depicted by this operator. And of course, there should be no space between these bars. It is true if either or both expressions are true, such as this one. We have the Boolean expression 1 and the Boolean expression 2. If both are true or either of them is true, this would give us a true result. For instance, we have the following expression. It will become true if x contains 1. And true if x contains the same value as y. And true if both comparisons are true. So that's how the OR operator works as opposed to that of the AND operator. We also have the NOT operator. What it does is it negates any Boolean expression and it is represented by this character. For instance, whatever is the result of x less than y, it will be negated if we use this operator. For instance, it will give true if x is not less than y. Then here's another example. True if x is not equal to y. The NOT operator can make expressions difficult to understand. Therefore, we can only use it when appropriate. As you can see, this is quite confusing. Therefore, we just have to use it if it's really necessary. How about inequalities? We should also be careful when translating inequalities in C++. For instance, we have this one. This can be translated in C++ in this way and not this. As you can see, it's really important to use parentheses to separate each of our Boolean expression. How about this one? Actually, I've already mentioned this a while ago, the difference between this and this. This one is your assignment operator, while this one is your equality operator. The first one is used to assign values, such as this one, like this expression. On the other hand, the equality operator is used to compare values, just like what we've seen in our Boolean expressions, such as this one. We would like to see if x or the value of x is equal to 3, which would give us either a true or false value. This is why we need to be careful. It's because if we accidentally type this expression our compiler would still accept this error. It's because this would be interpreted as an assignment operator. As you can see, what it does is it would store the value 3 in the variable x instead of comparing the equality of x to 3. Since the result is 3, as a result of the assignment operator, the expression will be interpreted as true. We also have compound statement. As we've seen a while ago, a compound statement is more than one statement enclosed in curly braces. This is what we've seen a while ago in our if-else statements. For instance, we have the following example. Next, here's another example. As you can see here, this if-else statement uses compound statements. And of course, as you can notice here, those compound statements are enclosed in curly braces. Now that you've learned about branches, you may want to try these exercises for yourself. We will now proceed with simple loops. In this case, when an action must be repeated, then we need to use a loop. In C++, there are several ways to create loops. Basically, a loop is a repetition routine in a C++ program. Let's have the first example, which is the while loop. This is how a while loop would look like. As you can see here, we use the while keyword followed by the condition, which is basically a Boolean expression. Therefore, if this is true, the following statements will be repeated until such time that this Boolean expression gives a value of false, which would end our while loop. If we are going to run this program, it is going to output hello 3 times when countdown starts at 3. In this case, if we will set this variable with an initial value of 3. Here's an example. Let's say we have the following example. In this case, we have the variable countdown. We will use this variable to determine if we need to stop our loop. Then we have the following. It will prompt us if how many greetings we want to display in our monitor. In this case, the number of times that we are going to print hello. Let's say we are going to enter 3. What will happen is that this variable will have the value 3, and therefore that will be part of this Boolean expression, which means while this variable contains a value greater than 0, we are going to repeat this compound statement within these curly braces. So what would happen is that if countdown has a value of 3, then we will make a comparison here. If 3 is greater than 0, therefore it is true. Thus, we will execute this, print hello, then subtract 1 from the current value of countdown, which will now give us the value of 2. Then we will go back to the top of our loop and make another comparison. So this time, the value of countdown is now 2, and we will make the same comparison. Is 2 greater than 0? It gives true. So therefore, we will repeat this statement, print another hello, then subtract 1 from the current value of countdown, which is 2, which will now give us a value of 1. Then go back to the top, perform the same arithmetic, uh, perform the same Boolean expression, comparing if 1 is greater than 0, which is true, then we will again print hello, deduct 1 from the current value of countdown, which will now give us 0. Then back to the top, perform the same Boolean comparison. Is 0 greater than 0? That will now give us false. So therefore, that would be the end of our loop, and we don't have to repeat this statement. So let's see for ourselves. So let's say I am going to input 3. As you can see, it will print hello 3 times. So that's a very example of how a while loop works. Now let's proceed. So how does a while loop operation works? As we have seen in the previous slide, first the Boolean expression is evaluated. If false, the program skips to the line following the while loop. Otherwise, if it is true, the body of the loop is executed. During execution, some item from the Boolean expression is changed, as what we have seen from the previous example, in which we need to update the variable that are being compared in our Boolean expression. After executing the loop body, the Boolean expression is checked again, repeating the process until the expression becomes false. We must also take note that a while loop might not execute at all if the Boolean expression is false on the first check. So what is the syntax for a while loop? Basically, this is how we should write our while loop. First, we must use the while keyword, then followed by the Boolean expression, which is true, then therefore it will execute the statements under this section, which is basically your compound statement. Semicolons are used only to end the statements within the loop, which also depends on the number of statements that we have inside our loop body. So if we are going to trace a while loop, this is how it is going to execute. As we have seen with the previous example, we must first look at our Boolean expression. If it is true, then our program will execute whatever statements are contained in the body. But of course, we also need to update the variables that are used in our Boolean expression to know if our loop would continue or not. And of course, we must be careful that we should not include a semicolon in this part. Next, we also have the do while loop. This is another variation of the loop that we had a while ago. A do while loop is always executed at least once. The body of the loop is first executed, and then the Boolean expression is checked after the body has been executed. This is how it looks like. As you can see, it is quite the opposite of what a while loop would look like. As you can see here, the loop body would be first executed, and then that's the time that we will look into the Boolean expression whether it is true or false. Then that would be the basis if the loop would return to the top and repeat what was included in the loop body. So this is the basic syntax for a do-while loop. First, you start with the do keyword, then the compound statements enclosed in these braces, followed by the Boolean expression that we have here, also including the while keyword. Then, of course, followed by the semicolon. We must take note of its difference to that of the while loop. Next, let's take a look at this. This is how we trace the execution of a do-while loop. As you can see here, it is important that we must start from where we see the do keyword, then followed by the loop body. We will execute everything enclosed in this section, after which we will look into our Boolean expression whether it is true or false, and that would be the basis. If it's true, then we will get back to the top and repeat what is inside our loop body. Otherwise, that would be the end of our loop, which is the do-while loop. And take note, we must not forget the final semicolon after our Boolean expression. Next, we have the following example. In this case, we would like to display the following message. And of course, it also depends on our input whether we would like to continue the loop or not. So we just have to answer yes. So let's try this. Okay. As we can see here, we are going to declare this variable of type character. Then we have our do-while loop. As you can see here, we will first execute whatever is enclosed in our loop body. Then, using our input in this cn statement, our Boolean expression will see if we entered yes, or in this case, the character y. If we entered y, then we will simply repeat this loop body. Otherwise, it will print goodbye, and that would be the end of our loop. Let's try this one. So this is the first execution of our loop body, as you can see here. A do-while loop would execute at least once, as opposed to that of a while loop. So for example, we would like to continue, so we will enter yes. Of course, it will keep on repeating until we enter a character other than y. So let's say we enter n for no. So that's the end of our loop and also the end of our program. So that is quite simple. As long as we understand the syntax of our while and do-while loop and also understand its flow of execution. When we are dealing with loops, it is also important that we understand the concept of the increment and decrement. In this case, we are using unary operators which require only one operand. For instance, we have the following. We have the increment operator, which adds 1 to the value of a variable. For instance, if we are going to do this, this is actually equivalent to this expression, which also adds 1 to the variable x. Same also with the decrement operator, only that we are performing subtraction. Next, here's a sample program. In this case, the bank would charge a card balance of $50 with a 2% per month interest. Then, we have to know how many months without payments before your balance exceeds $100, and we have the following computation. Here's our sample program, but of course, it would be better if you will run this example by yourself so that you would understand how loops work by running this program, and of course by studying this sample source code. I hope that you would study this example so you would understand how loops work. We also have what we call infinite loops. As you can see, when we say infinite, it never ends. So therefore, it is also possible for loops to execute infinite. Loops that never stop are called infinite loops. The loop body should contain a line that will eventually cause the Boolean expression to become false, just like what we have in the previous example, whether it's a while loop or a do-while loop. There should be some way to update the variable in our Boolean expression so that it would eventually become false and therefore ends our loop. Here's an example. We would like to print the odd numbers less than 12. For instance, we initialize our counter variable to 1, then use that in our Boolean expression. Then we have the following Boolean expression which will determine if our while loop would continue or not. As you can see here, x has an initial value of 1, so therefore we are going to determine if x is not equal to 12. Therefore, it is true, so we will execute this, output whatever the value of x is, then update our x using this operation. So if the current value of x is 1, then plus 2, that would be 3. Get back to the top, then perform the same Boolean comparison. Is 3 not equal to 12? It's still true. Then plus 2, that would give us 5. Plus 2, that would give us 7. Plus 2, that would give us 9. Plus 2, that would give us 11. Then plus 2, that would give us 13. As you can see, we will keep on adding 2 to the value of x, and it will always be not equal to 12. So therefore, this Boolean expression will always give us a value of true. Therefore, this loop will never end. Actually, what's wrong with this loop is that we did not use the right Boolean expression. Instead of x is not equal to 12, we should have used x is less than 12. Next, we now know how to use branching statements as well as how to use simple loops such as while and do-while loops. We can now try the following exercise by ourselves. I hope you try this simple exercise and determine if you can now comfortably use while loops in your C++ program.